Guys, good evening, and I'm very happy to meet you guys again in this TCS CodeVita session. So this is going to be a very interesting session because in just few days we are going to have a zone one round one zones. Uh, so I hope you guys are all excited and you guys are preparing for last minutes. Okay. So whenever we are going for any semester examinations, we used to have last minute preparations. Okay. So I'll just quickly give you a simple, uh, you know, simple strategies and tips to how to identify a particular program and how to solve programs on this. And we'll also discuss one mock question. Okay, when it comes to TCS CodeVita, we have discussed it several times. Okay, we have six questions to be yeah, we have answered this in 6 hours. Okay, in a 12-hour time period. Yes. So in that case, okay, so the first questions will be first two questions, let us say, will be based on normal strings or arrays and something like that. Okay, and the third and fourth questions will have higher difficulty level based on let us say data structures and algorithms. Okay, it might have concepts of data structures and algorithms. Fifth and sixth will have a very complex competitive programming level of questions, and that's how things will be categorized. Okay, so when you talk about fifth and sixth questions, it might be even harder than the hard level questions in lead code. Okay, so that's a overall view about how the difficulty level will be in your TCS code beta. Okay, so prepare for it, and so what we will be doing today is we will be discussing one mock question from one of our previous TCS code beta examinations. Okay, see, this is very important. This TCS code beta is very important because we have again, we have, as usual, we have three different packages. People can get direct offers from just participating in this competition. Okay, and not only that, you will also have exposure to the world level competitors. Okay, so these are some very important reasons that you should definitely give your best in your TCS code vita. Okay, so if you are able to score complete three to four questions right, you might get digital role. Like if you're able to get two to three questions right, you can expect ninja role, and five or six you can definitely expect a call for the topmost package of the company, which is Prime or Innovator or something. Okay, so that's it. So these are the reasons why you should give your 100 percentage. And one very important thing to test yourself. Okay, how good you are at it. Okay, so these are very important reasons. And what are the strategies? We'll quickly just discuss some simple ideas and tricks. Okay, you can follow various. First, try to categorize which question, which topic this question comes under. Okay, so given a question, okay, ask certain several questions. Okay, so let us say, uh, like, what kind of question is this? We need to understand that. Okay, so first of all, can I solve this question? Based on some conditions and based on some, like, let us say, if I can solve this question using recursion, can I optimize it using DP? Okay, you can ask several questions on the question itself, and try to find the answers. Okay, based on that, you filter out which method you are going to use, and then you can apply them. It's as simple as that. Okay, so if it is going for backtracking approach, you can find it out, and same way. Okay, so if you don't have a, like, let us say, if you're going to work with graph, mostly you will be working with a greedy approach. So these are all some scenarios where you can work with. Okay, ask the questions. Okay, try to answer it, try to filter based on this question, try to filter which topic this question comes under, and then what you can do is you can just solve it normally. So for simplicity purpose, what we'll do is today we are going to take one mathematical program as in TCS code, which is of medium difficulty level. If you know some basic mathematics, okay. So that is what we are going to do today. Let us look into the question now. Okay. So the question says that dining table seating arrangement. That's the title. Okay. Let us see. In a conference, attendees are invited for a dinner after the conference. The coordinator Sagar around arranged round tables for dinner and want to have an impactful seating experience for the attendees. Before finalizing the seating arrangement, he wants to analyze all possible arrangements. So there are rounds or round tables, n attendees, in case where n is an exact multiple of odd, the number of attendees must be exactly n by r. N is not exact multiple of r. Okay, when it's not multiple of r, then the distribution of attendees must be as equal as possible. Okay, so let us understand what is the problem statement here first of all. Okay, see, you will be given with two inputs. One is the value of n. Okay, you will be given with the value of n, and you will be given with the value of r. So n means number of attendees, number of attendees. Okay, and here we will be having the second part, which is round tables, number of round tables, number of round tables. Okay, so in that case, if that is a scenario, okay, so now what we have to do is, okay, we have two conditions. What are the conditions? The first condition says that, okay, if there are like if the number of attendees is exactly say it is divisible by r. Let us say we have three tables. Okay, three round tables. Okay, I have drawn a shape, but actually it is round table. Okay, it's a looping table. Okay, no issues, they are going to sit around the table. Okay, now let us say I have four tables here. Okay, I have four tables. R is 4, and let us say number of people is 12. If number of people here is 12, then how are we going to arrange them? Okay, this is the condition. So in that case, how are we going to arrange them? It's very simple. Okay, we will just divide them equally. Okay, so in that case, how many arrangements, how many ways are we going to, how many people will be arranged in each table? I'm sorry, how many people will be arranged in each table? Very simple, 12 by 4. Yes, 12 by 4 will have three people in each table. Okay, so as given in the question, we have to divide people across the given round tables as equally as possible. Okay, so the first condition is if n is perfectly divisible by r. Okay, what is the total number of people per table? Total number of people per table is 3. Okay, now we have the second condition. What is the second condition? The second condition is if n is not divisible, if n is not divisible by r. Okay, so what we have to do then? How can we solve this scenario? Okay, this is going to be quite interesting. If n is not equal to r, how to solve this? Let us see. Okay, now what we are going to do is, first of all, we'll understand the arrangement here. Let us say, let us take n equals to 14. Okay, let us take n equals to 14, and let us say r equals to 4. So what I will do, I'll have four tables. I have four tables. And what is the question? The question is, I have to divide these people and make them sit across the given available tables as equally as possible. So I'll simply divide this 14 by 4. Let us say if it is 12 by 4, if it is 12 people, I will just divide them by 4 and make them sit in four tables. Okay, so 14 by 4 gives me 3 as a quotient. Okay, 14 by 4 gives me 3 as a quotient. Okay, now let us look at this. So which means we'll have 3 people per table. But what is the reminder? We have 2 extra people here. We have 2 extra people. We need to make them sit. Okay, we need to make them sit. Where can we make them sit? We have to, we should not put these two people together in the same table. So what we will do now is, okay, we'll add one person per table in let us say some random tables. Okay, in any of the two tables here, because the remainder is 2, I'll take any random 2 table, I'll just add one person to it. Okay, okay, so what happens now? We have 3, 3, 4, 4. So in this table we have 3 members, in this table we have 3 members, in this table we have 4, in this table we have 4. What is the question now? The question now is, we need to find in how many different ways we can arrange them. But one interesting thing here is, let us say this is a circular table, right? Now let us say 1, 2, 3 is arranged. Okay, and then this is like there is another arrangement like this 1, 3, 2. Okay, these two are considered as exactly same arrangements. These two are considered exactly as same arrangements. So if that is the condition, okay, we have to find how many people, how many different ways can we arrange these 14 members in 4 tables such that okay, people are spread across our tables as equally as possible. Okay, so that is the problem statement, guys. Now let us break down this question in a simpler way. Okay, now let us look at this. First of all, okay, if let us consider this case, I'm sorry. So n is 14, r is 4. Cool. This is very interesting. All right. Now what I will do is I have to find how many people will be there per table. Okay, we have four tables here: one, two, three, and four. So according to our previous categorizations, we had two tables with three members and we have two tables with four members. Why? Okay, when I divide this 14 by 4, okay, the quotient, okay, gives me 3. And when I divide this 14 mod 4, okay, the remainder is 2. So which means when I try to spread them across equally in all tables, okay, definitely there will be three people per table. And after arranging three people per table, how many people are standing out extra here? We have two members who are standing out extra. So I'll arrange them in some random two different tables. Okay, so now we have this arrangement. Now the condition here is very simple. Look at this. So we are going to name this tables. We are going to categorize these tables. Let us categorize them as A tables, B tables. Tables A, tables B. Okay. One simple thing that you can observe here is I'm going to categorize all the tables with count 3 as table A. I'm going to take all the categorize all the tables with count 4 as table B. If that is the scenario, if that is a scenario, okay, how can you find number of tables in how can you find number of persons in table B? Let us say PB. How can you find number of persons in table B? Number of finding number of tables in persons in table A is very simple. Quotient, find the quotient. That's it. You have three here, right? So how to find PA? It's very simple. Just divide n by r to find number of people in table A. So how to find number of people in table B? It's very simple. What is the relationship between 3 and 4? Plus 1, right? So number of people in table B is always equals to PA plus 1. Done. So now we have found the number of peoples in table A, number of peoples in table B. Okay. So these are some basic conditions. So now what we will do is, let us consider this case and let us try to build up some formulas to solve this case. All right. Now we are going to solve one simple scenario here. Okay. How many ways can I arrange these people? How many ways can I arrange these people? I have 14 members. Okay, if I have n members to arrange, in how many ways can I arrange this? It's very simple. I can arrange them in 14 factorial ways. I can arrange them in 14 factorial ways. Okay, but there is one simple thing here. Okay, there are some, let us consider this case. Okay, I'll just make it simple for you. Consider this case. How many people are there? Let us say we have A, two A's and two B's. We have two A's and two B's in this case. Now, how many ways can I arrange them? This is the question. How many ways can I select these people? First of all, we need to select and then we have to arrange. Okay. So first we are in the process of selection. Okay. First we need to select. Okay. So in how many ways can I select these people as a unique, elements? How many ways it's possible? Okay. That's what we are going to look for. Okay. So let us consider this case. So I can, if I have four tables, I can arrange in four factorial ways. I can arrange them in four factorial ways. Now we have two duplicates here. We have two duplicates here. So how can I remove that? So I'll just say 2 factorial by 2 factorial. Okay. So this is how we are going to first find the number of selections. Okay. Just give me a minute. Alright guys, so let's come back here. I hope I'm audible now. Okay, fine. So what we are going to do is we are going to apply these simple strategies in our program. Okay, so first of all, we need to find the total number of division. How many ways I can divide these people? Okay, we need to find this division here. So let us find the division category easily. Okay, so how will I divide this? It's very simple. I have 14 members to arrange in 14 factorial ways. Now we have these two tables. We have tables in P we have tables in uh, A. We have table A, table B. Okay, so in that case, to arrange to select people. Okay, if I have to select like we know we have PA, right? So number of people is A. So how to find the possibilities for selecting these PA people? So we know that it is PA factorial. So for finding for selecting n people from n members, okay, for n different positions, okay, the formula is mathematical formula for this is very simple, PA factorial. Now what we will do is we don't have only one PA table. We don't have only one A table. We have TA number of tables. Okay, total number of table A. Let us say that is TA. So we might have this much number of tables here. Okay, same things for PB. Okay, so PB factorial by power T power B power TV. So which is this is nothing but n. So n factorial by yeah. So n factorial by PA factorial by power TA PB factorial power TB. So this will give me total number of ways I can divide the elements. So let us put this together and we'll just apply this in formula. So now we know how can we divide these people. Now after dividing these people, we need to know we need to arrange them as well, right? So what is what is the question? We need to find total number of ways to arrange these people. So I have divided these people now into different tables. After dividing them, we need to arrange people in this place. Okay. So let us take that as x. Now we need to find this x. What is this x? This is nothing but selection. How to select people for different tables. Okay. This is the formula for it. We have derived it. Now let us see how to find this x. What is this x? Number of ways to arrange these number of peoples in these number of tables. Okay. Now let us see how to do it. It's very simple, guys. Okay. So to arrange these people, let us go for general arrangement. Okay. If I have to arrange n people, okay, if I have to arrange n people in n different places, I have to go for n factorial ways. Okay. For an example, let us say if I have three members, okay, in this first place I can take three members. In second place, I one of these three members can be placed here. Okay, remaining will have two members. One of these two members can be placed in this position. Remaining will have only one person. So total number of possible ways 3 to 2 into 1, which is 6 factorial here. Yes, sorry, not 6 factorial, 3 factorial. 3 factorial, which is 6. Okay, so this is how we usually do, but this is for linear arrangement. In linear arrangement, we have a critical, we have a clear, visible, okay, edges on both side, left side and right side. This is the starting element, this is the ending element. But what are we talking about now? We are talking about circular arrangement. When we are talking about circular arrangement, okay, there are a lot of constraints which will come into play. So for an example, let us say we have person 1, we have 2, 3. And then let us say we have 1 in this place, 2 in this place and 3 in this place. Do you think that these two people are different? These two arrangement are different? Definitely no. They are one and the same. Okay, look at this. 1, 2, 3, 1, 2, 3. They are just one and same. Yes. So in that case, we cannot consider these as two different arrangements. In that case, we cannot consider these things as different arrangements. So if I cannot consider these people as different arrangements, okay. So how to find the total number of possibilities? Okay, it's going to be quite simple. I have to fix one of these person as a reference. Okay, so I will fix this person. I'll move only the remaining people. Okay, because here one is in this place initially. Now if it's in this place and it can take any other place, but if it keeps changing, okay, I cannot find the total number of ways to arrange elements inside a circular arrangement. So to have a particular idea, what I will do is I will take one person and fix that person as a point of view. Okay, now with this person as fixed, I will arrange the remaining people. So if I have n members, so for 3 members I am fixing 1 and I am going to rearrange only these 2 people. Okay. So for n members I have to arrange only n minus 1 people. Okay. So for n members in linear arrangement, if it is n factorial, in circular arrangement it will be n minus 1 whole factorial. Simple as that. Why? Because I'm going to fix one person and I'm going to arrange the remaining. That's it. So that's why I have to subtract 1. Okay, now there is one simple issue. What is it? So consider this case. 1, 2, 3. 1, 2, 3. Now, even if I fix these people 1, okay, what happens to this place? These two are just mirror elements. Yes or no? 1, 2, 3, 1, 2, 3. These are just mirror elements of each other. So can I consider these as your same element or like unique elements? Okay. So definitely these are nothing but same element. So I have to remove these kind of duplicates as well. So to remove these kind of duplicates, if I have, let us say 2, I will just take 1. So how can I take this? I'll just divide this by 2. Simple as that. Okay. So this is the formula to find number of arrangements in a permutation. Okay. So now let us put these things together. So let us take for case A and case B. We have two tables, table A and table B. For table A, what we can do, right? So it is number of people in table A, which is n minus 1 factorial, n minus 1 factorial by 2. Okay, so will we have only one table? No, we can have TA number of tables, right? That is another interesting thing. Okay, now let's go for this. Alright, guys. So I hope now I'm audible. Okay. So let's come back here. So whatever we did for table A, we'll do it the same thing for table B here. So PB minus 1 whole factorial by 2 power TB. Okay. So this is the total number of ways this is the total number of ways for arranging these people. Okay. Yeah. So now what we will do is we have the total number of selection or division from the previous formula that we calculated. Okay. Now how will you find the total number of arrangement? Okay. So I have selected some people and these peoples can be arranged in this much number of ways. So we'll just multiply these two tables, selection, whatever formula that we use for selection, we'll multiply that with these arrangement formula. Okay. So when you do this, you will have a simple answer. Okay. So that's it, guys. Let us simply go for a pseudocode here, and then we'll move into. We'll just quickly see the pseudocode, see through the pseudocode, and then we'll start solving the program. All right. So what is the pseudocode? The first step here is okay. Find the persons in number of people that can be occupied in table A, number of people that can be occupied in table B, and total number of tables in A category, total number of tables in B category. How are we going to do that? It's very simple. So PA is nothing but total number of people by the total number of tables. So what is PB? PB will be just nothing but one excess than PA. Okay, now we know PA and PB. Now how to find total number of tables of A? So total number of tables of A is going to be very simple, right? So what we will do now? Yeah. So yes. All right, guys. Fine. So what we'll do now is we'll take this TA. How will you find this TA? TA is nothing but n mod r. So the total number of the remaining people will be nothing but you know will have the lesser values. Okay. So now after finding these people, okay, after finding these people, now we have to find the total number of tables for B category. Okay, which is going to be very simple, which is nothing but total number of tables are minus total number of tables in A category. Okay, so when you do this, we will be finding all these four things. After finding this, what we can do is we'll have some base conditions. Now, when you look at this circular arrangement, we have 1, 2, 1, 3. Yes. So when you apply this logic, okay, when you apply this particular condition, okay, we have this case number of people, okay, and if it is greater than equal to r, okay, sorry, number of arrangements, number of round tables, if it is greater than equal to number of people, then what happens if I have only 5 people to arrange but I have 6 tables? I have 6 tables, 1, 2, 3, 4, 5 and 6 tables. Okay, so what will be the possible ways that I can arrange the elements? I can arrange only one person per chair, right? So we'll set that as our base condition. So if r is greater than equal to n, okay, I'll simply say, okay, we have only one possibility. Okay, we'll just return one in this case. Okay, one per person, one per table is the maximum arrangement that we can do. So we'll take that as consideration. The next thing is we will find the total number of ways to select people to seat in the tables. After selecting them, we will find total number of ways to arrange those selected people, and then what we'll do is we'll just multiply selection and arrangement. So that will be our final result. Okay, so that's the logic, guys. So we'll quickly move into the execution part, and I'll be doing this in C++. Okay, so I hope you understood the logic. So if you're done with this, we'll quickly move into the coding part for this. I'm sorry, guys. Just a bit of connectivity issue. Yeah. So in this example, we can see we have the first condition is we need to find the number of test case. We need to solve for the number of test case. So let us take the input for test case here. Okay. So for each test case, we'll have a different number of n's and r's. Okay, a number of like if I have 5 test cases, I'll take 5 different scenarios. Okay. So here we have let us say 2. So for that we have to iterate for each element. We have to get the n and r values for it. So let us iterate here. Int I equals to 0, or let us say I equals to 1, I less than equals to test case I plus plus. Okay. So let's iterate through this. So on my iteration, so what I will do is I'm going to take for each elements, I'll take tables and attendees. Okay. So let us declare these two variables, tables, attendees. Cool. So for each scenario, I'm going to take two inputs, which is tables and attendees. And let us handle the base condition right away. What is the base condition? If tables is greater than equal to attendees, I told you there is only one possible way, right? So we'll directly return one here, or we'll just directly say, okay, the output is just one. Okay, so we'll just say cout one. That's it. So if this is not the case, then that's where things get interesting. Okay. So what I will do, if this condition is not true, then we have to do the regular calculations. The first thing is we have to categorize PA, PB, TB, and TA. Let us check it out. So we'll first find PA. Okay, I'm just going to name it as PA, PB itself. So PA, comma PB, TA, TB. Okay, let us name these variables like this. Let's come back here. I'm going to say PA. Let us calculate the value of PA here. So value of PA is nothing but uh, attendees N by R. What is R tables? We'll just divide this here. So what is PB we discussed? PB is nothing but PA plus 1. Cool. Now how to find the total number of tables in B? So total number of tables in B, we just discussed it as attendees modulo tables. So let us say we have 14 members, okay, to arrange in 4 tables. So when you divide this, the number of tables per person is 3. How many people are extra? 2 people are extra. So that those extra people will be seated in PB, right? So which is those extra people will be going and sitting in B tables. Okay. So how many people are extra? Attendees by mod tables, which is 14 by 4 will have 2 as a reminder. Okay, that is nothing but the total number of tables. So two tables in our case will be nothing but of category B. So now let us find total number of tables in category A. It's nothing but very simple. So we know the total tables minus TA or TB. Sorry, that's it. Now we have found all these required parameters. What we will do now is I'm going to create a array for finding factorial, because you can see in our formulas I found factorial in many places. So to avoid that, okay, if I have to find 5 factorial, then I have to find 20 factorial. Okay, that will be very hectic because every time I have to start finding from the beginning. Okay, for if I want to find 20 factorial, I have to first find 1, then 2, then 3 factorial, 4 factorial, 5 factorial, and so on. Okay, so to make this process simpler, we'll use the concept of DP here. We'll create an array to memorize the elements. Okay, so this factorial can take a long value, so very long value. So I'll just go for a long type array here. Okay, long int factorial. Let us take it off size. I'm sorry, I have to declare it inside here after getting the attendees. Okay, so we'll create this of size attendees plus 2. Okay, and then we'll just create 2 more variables to work with this. So long. We'll first see how many ways I can select the elements, right? So I told you 2 formulas. So first we'll see how many ways we can select the elements, and then we'll see how many ways we can arrange those elements. Okay, so these are some required variables, and then let's start with our calculations. So to start with, we know 0 factorial is 1. So I'll make factor of 0 as 1, and then we'll start our for loop to find the factorial values. Okay, so let us say for int j equals to 1, j less than equals to attendees plus 1, j plus plus. So what I will do is I'll find factorial of each values. So how can you find it? So if you want to find factorial of 4, you have to multiply all the 3 factorial into 4, right? So same way. So how will you find factorial of 3? 2 factorial into 3. So just the previous factorial value into the current value. That's how simple is this. So I'll say factor of j is nothing but, okay, previous factorial value, which is factor of j minus 1, factor of j minus 1 into j. Simple as that. Okay. So once we are done with this, we are ready with factorial values. Now we can implement our formulas. We had discussed 2 formulas, right? Let us apply it. The first formula is for dividing the elements, for selecting the elements. So let us say fact of attendees. We'll find the factorial of attendees here. Okay. That divided by, let us find the power of factor of a. We'll find factorial of PA, comma TA. That's it. So this will give you the number of people in this particular range. Yes. Now, same way we have to go for B element as well. Let us try this out. Okay, let's do the same thing for B now. Power of fact of PB comma TV. Okay, which is total number of tables in B category. Alright, guys. So we are done with the first set. We are done with the first set here. We have found how the like how many ways we can how to select peoples in this range. Now what we'll do is we need to go for the next case. I'll tell you here. We have one interesting scenario. What is it? Okay. For arranging the elements. For arranging the elements, let us say if I have only three people, how many ways can I arrange them in these three people? Like if I fix one, I have to arrange only two. Okay, so we know that n minus 1 factorial by 2, right? So formula for this is, okay, let us try to apply the values from 1 to 3. Okay, when I apply 1 here, 1 minus 1 is 0, 0 by 2 is 0 again, 0 factorial is 1. So same way, let us apply the value for this as 1 here, 1 will, sorry, 2 here, 2 minus 1 is 1, 1 by 2 again. So in this case, we'll have the answer is 1, and again when I apply 3, 3 minus 1 is 2, 2 by 2 is 1, so 1 factorial is 1. So in all these cases, okay, so for 1, 2 and 3, for 1, 2 and 3, in all these three cases, okay, the output will be 1. So the the arrangements, for arrangements, the output will be 1. Okay, I'm not talking about the entire set, I'm talking only about the arrangement. So basically what is it? Finally the result will be nothing but, okay, divide number of ways we can divide into number of ways we are going to arrange. Yes, this will be our final answer. But in this case, what happens here is if we have less numbers, like if we have n values which is less than equal to 3, then this arrangements will become 1. Okay, there is only one possible way to arrange them. Okay, so that's a scenario here, and let us try to implement it here. So if PB, because P B is nothing but the table with the largest people, right? So PB is equal to PA plus 1. So it is enough for us to check for B alone. We don't have to check for A. So if PB is greater than equal to 4, then what we can do is then we can implement our simple logic. Okay. If it is not the case, then definitely what we have to do is we can just multiply multiply it by 1. Simple as that. Okay. So arrangement, total number of arrangement is nothing but selection. Okay, the division I have done here, so which is division into the arrangement formulas that we have just derived. What is it? So pu power of facts of pa n minus 1 factorial by 2. Let's apply it for this fact n minus 1 factorial by 2. So actually this bracket will be coming to this point. Yes, yeah. So power of n minus 1 factorial by 2. Let us take this by 2, and same way we'll do the same thing now for B as well. Okay, into this, let us make this as B. One more thing, we have to give a parameter here. I'm sorry, comma TB. We have to find the power of this to TB. Sorry, this is A and that will be TB. Okay, cool. You don't need a bracket. We have extra bracket here. Okay, cool. So now we have found with the arrangements here. So what we have to handle the else condition. So in else condition, we'll just simply say arrangement is nothing but division number of ways I divided into 1. So which is basically nothing but divide itself. So we don't need to give into 1 separately. Okay, so that's it. Now we have found the arrangements, total arrangements. We can just print it out. Simple as that. Okay, so that's it, guys. I'll just come out of this else statement and I'll say cout and we'll print the arrangements here. That's it. Okay, so I'm sorry. All right. So that's it. So let us just quickly run this out. I'm sorry. Cool. If we have any errors, let's debug this. Okay, so here I'm going to start from 1. Okay, so library files, that is just include all the library files here. Let's dash stdc h. All right, so we have run this code and now it worked. So that's it, guys. So the logic is very simple. I'll just go through it again one more time. So we will be just creating a factorial. First of all, we just check this base condition. If number of table is greater than equal to attendees, okay, there is only one possibility. So I'll just say 1 and I'll just close it. Or else, what I will do is, I will find PA, PB, TB, and TA. Then we'll find factorial for the maximum value. The maximum value is nothing but if I have 14 members, the maximum factorial value that I will be needing is 14 factorial, right? So I'll be finding factorial values till the maximum number, and then we'll start our calculations. So first we'll find how many ways to divide people between the tables, and then we have to arrange those people. That's it. So after finding the arrangement, we'll just print it out. So that's our simple logic, guys. I hope you understood this, and like all the best for your upcoming CodeVita hackathons, and do well. Okay, so